Hi again. In this session, what we will try to do is to look at, continue our discussion on life tables, and we will look at a concept called select mortality. So in select mortality, the idea here is very basic. I mean, imagine that somebody with terminal illness goes to apply for a private life insurance. There is underwriters. They will the underwriters that they work for the life insurance. They look at the profile of the person. Then they know that this person will die within 1 month. So they will not issue the life. They will not issue the life insurance because they know that this is. Like the person who applied is applied just to get the payout of $1 million or whatever the value. So the idea here that because individuals go through the underwriting process, it means that the ones they are selected are at lower probability of death or mortality, lower mortality rate than the general population. Why? Because of the underwriting practice. And this, what we can look at it is, we'll give it a new term for us to differentiate between the general mortality rate and the select mortality rate. And we mean by the select is, again, like the ones that selected for the insurance company through the underwriting process. So usually what we did, we looked at QX, right? Example like Q70 is the mortality rate of an individual who has reached the age 70, the probability for her or him to die within 1 year, right? Q70. For the select, we'll give it a new term like this, QX, right? When you see this, just to tell us the information that we get when we see it, this Q brackets X, is that X is selected at age 70. So this is, for instance, Q, I mean 70. The difference between this and this, the second one here, it says the same thing. The probability for an individual at age 70 to die within 1 year. But there is additional information with the brackets. The brackets say that that person was selected or insured at age 70, at exactly age 70, right? So that's the difference. The first one, it doesn't say anything about when, like this one doesn't say anything when the person was issued insurance or not. So this is general population, and this one is select. We usually use for select, for general we use ultimate, and this one is select. We'll come back to ultimate, why it's said ultimate, right? But just like the idea is to say, to give us like these brackets, they give us information about that when they were issued insurance. The 70 is the age, right? So it was issued insurance at age 70. Let's take also like another, let's visualize it. Maybe it's better to visualize it. So let's say here we have an individual. When we see bracket, it's at age X that individual was issued the insurance. Next year, the individual will not write it will write it X plus 1, but we keep the X in brackets. Example, like let's say 70. We continue to write it. We don't write it 71. We write 70 plus 1. Yes, 70 plus 1 is 71, but we don't write it 71. We keep the 70 in the brackets because the practitioner, when you read it, you understand that the individual was issued the insurance at age 70 and now the age is 71, right? So this continues, right? You can write X plus 2, keep it here, but it doesn't stay forever, right? It doesn't stay forever. There is a period, maybe X plus K, maybe minus 1, but after this one, X plus K becomes. Maybe I'll give you like the example. We continue 70 plus 2, maybe the 70 plus let's make it just 3 and then 74, right? So here we have the select period. So in new term, in new notation here, select period is denoted by K. So the period that we keep the practice of putting brackets to say that the mortality rate of these two individuals are different because one was issued insurance and one is not, for a period of K. But because remember when I said that when somebody issued insurance, usually at lower probability of death or lower mortality rate than the general population, because that person was selected or was underwritten, so went through the investigation. Right? But this over time, it actually like they converges. The two probabilities, they converges. When they converges to become equal, like the general population and the ones insured, it's over a K period. So it might be 1 year, 2 years, 3 years, 4 years, whatever the reason. But what I wanted here, if you compare this, the idea here is to KQX is less than QX brackets. And why is that? Because it's again like coming back to the same idea. If somebody is just selected or issued insurance, it means that he or she went through the underwriting process. So they were a team of underwriters. They looked at the profile, the health profile, and they make sure that there is no tail. So that tells us that the probability of mortality is lower than the general population, right? So we keep, for how long we keep the brackets, it's for a period called select period. Let's take one example. Maybe I'll share with you just is library image. Let's make it a little bit bigger. Oh, not this one. Sorry, let me take this one. We need select mortality. Let's make it bigger. Right. So this is select mortality table. It seems. Right. So this is basically, let's take a few, let's look at somebody's age 30. Let's take this one. Let's say for someone who has just been issued. So for just someone who has been just issued insurance. So the insurance policy. So the insurance policy was issued on his 30th birthday. So for someone who has just been issued insurance policy, on age 30, we write it this. The mortality now, mortality for this person, mortality for this person follows this way. So we have somebody issued age 30. Right? So mortality for this person. So what does this tell us? Mortality that or mortality rate, or yeah, let's write it differently. So probability for him to die next within a year. So the probability for this person who at age 30 was issued an insurance policy, the probability for that person to die within 1 year is, we write it this way, Q30 in brackets. What the brackets tell us that he has just been issued insurance. And what's the probability? What's the probability for this is, see it, it's here. So this is 30. Now we don't write it 31, remember, 30 plus 1. So this is the probability of death here, right? So we don't write it 31, we write it 30 plus 1, right? We follow this table, right? So let's take another example, maybe, or what is Q30 plus 1? How we can read this one? So like this is at age 30, at age 31. So at age 31, now this is what it tells us. When you read it, the first part here, you say what we see, somebody at age 30 and on his birthday was issued a policy, and today his age is 31. So what is the probability for that person who was issued insurance at age 30 and now he's 31? What's the probability for him to die within a year? So now this is 30 plus 1, 30 plus 2. And if you look at this probability, you go back to the table. Now this is 30, we are here, so we are here, 30, and this one, right? Do you see it? 0.555. Same thing at age 32. Now we write a Q30 plus 2. Right? And this one, same logic. We go back to the table. Now we follow somebody's at age 30 was issued insurance and now the age is 32, so 0.65. And if you visualize it here, 30. So was issued the insurance at age 30, now 30 plus 1, 30 plus 2. So what's the probability to die here? And let's go back, because now we're getting into new area. Now after 30 plus 2, you have you don't have brackets. So it tells us now the select period ends. So the here we don't have 30, it becomes 33. Right? So what's the probability here to die here? Right? So this is what we call it the select period, right? So that person at age 30, at age 31, 32 will have mortality different than the general population, but at age 33, right? At age 33, we write at age 33. If you write it this way, is equal to Q33, right? So you don't really need to write it this way. Just you write it Q33. Why? Because the select period ends. So this one is just 30. We don't care, like 33, 34. So there is no information, like we don't know when that person was selected the insurance, right? It doesn't say, unless we see the table, then we can trace, right? So now this converts with the general population. Right? It's simple, it's not difficult, right? So what I wanted you to see, look at this one, let's say Q33. But if somebody, this one here, Q33, so this one here, somebody at age 33 was issued insurance. And what is the probability for her or him to die within a year? This one, this is the general population, Q33. What you notice as we discussed, let me write it here, Q33 should be less, right? Because we already discussed this, right? So if somebody issued insurance selected at this age, it means that he or she has lower probability than the general population because he or she was selected. Ultimately, he or she will after 3 years, after the end of the select period, ultimately he or she will be converged with the general population. And this is why we get the notation select and ultimate, right? So ultimate and select. So when we hear the word ultimate, it means that this is the general population, like the general probability. Select is the select period, the period that's still at lower mortality rate than the general population, or different than the general population because of the underwriting practice, right? Does that make sense? Should be straightforward. Let's take example here. What I wanted to do is to find for P30. But just let me have it one more time, you know, like the same image, so don't need to keep going back. So I don't want to keep going back. So now we need to find P, maybe I can take it a little bit here. So the question is to find for P30. Again, for P30. What's for P30? Oh, sorry, and select. So an individual at age 30 was issued insurance. What's the probability for that individual to survive 4 years? So at age 30, individual is selected, right? So we have now 30. We don't write 31, we write 30 plus 1, 30 plus 2, then 33, 34. So for this individual, what's the probability to survive? Right? 4 years. So 1, 2, 3, 4. We need 4 years of survival. Simple, right? Very simple. For P3, we need to look at this individual and trace the probability. So for P30 is this individual to survive year 30, then survive year 30 plus 1, then survive year 30 plus 2, then survive the year 33, then survive, sorry, not multiplication I meant, then survive the year 30, oh no, not 34, that's enough. Right, so you need this individual to survive 4 years, right? So this P30 is 1 minus Q30. Let's look at Q30, this one, right? And we go this way now. Go this way. X plus 2, 1 minus and the last one is 1 minus this multiplication, right? Multiplication. Oh, I forgot 0.75. Right, you need to multiply them quickly. So if you multiply them quickly, 1 minus 0.45 multiplied by 1 minus 0.55 multiplied by 1 minus 0.65 I got this answer. Right. So you see, I usually, if you remember, I told you sometimes it's good to throw, you can do it this way, it's not difficult. But if you want an alternative way also, I usually do this way. I just put, like we said here, we need to start from the question 4p 30 plus 1, alternative way, let's say. What I usually do, I start with L30. I just assume a number. I assume a number. Then it's the same logic. So now L31 and then I keep multiplying 1 minus this with 1000. The last number here will be, if you do this, will be 780.5, right? Will be L4 34, and then 4p 30, if you do it this way, will be L34 divided by L30. We keep the select plus 4. You can verify it. I don't want to repeat it. I did it quickly, but you can verify it yourself. You should get the same answer as you got in previously, right? If you do it right, it should give you the same answer. I usually use this method because this one is just like lots of numbers, not too many fractions, and I can keep everything in the calculator and keep going, keep carrying this equation. But let's take a few examples here. Let's take another example. I just put it here so we can go quickly to solve this equation. We'll use the same table we created, so let me put this one here and let me make it larger. And let me just get the same table here. Just to remind us of what we were doing. So now I want you to read this equation and we can work it out together. So we have Mr. A and B. We'll start with Mr. A first and then we'll come back to Miss B. Mr. A, the question tells us, we need to be careful when we read these questions. The question what tells us, now this is in duly selected life on 2010. So let's have 2010, 2011. Let's first have the years. And we have 2001, 6, right? So Mr. A was selected on 2010. In 2011, he was 31. So he was selected at age 30. So selected at age 30. Right? Why? Because he was selected on 2010. In 2011, he becomes 31. So if he's in 2011, he is 31. So in 2010, he was 30 years old. But in 2011, we don't write it 31. We write 30 brackets between plus 1. Why we do that? Simple. We do that because to tell us that this life was selected in age 30. We don't need to read the whole story. Once we actuaries, we see the notation, we understand what it is. So now 30 plus 2, because we're using the same table here, we know that it's a plus 2. Sometimes it's not, it can be more than this. So it depends. So for us here, 2 years. So it depends on the table. The table can be different, but like for this example. And after that, it becomes 33, 34, 35, 36. Let's see what's the question here. So Mr. A newly selected in 1/1/2010, 31. Now find the probability on 2011. So the year of evaluation is this year. Why because this goes to the denominator. Once you know what year of evaluation, it means that this is what goes to the denominator. Find the probability that on 1/1/2011, Mr. A will be alive on 1/1/2016. So be alive, it means that we need the survival. So we need the survival. The best way, we need to find the probability. The best way to calculate this probability is survival, right? How we can calculate this probability because it's survival? The best way is to say, is to take a cohort and see the cohort at 30 plus 1, and then see the cohort at 36. And this, by the way, it's 1, 2, 3, 4, 5. So this 5, if you wanted to write it, P 30 plus 1. Right? Right? So this one, but just let's not confuse ourselves, keep it, just focus on this one. Like the question is find the probability on 1/1/2001 that Mr. Will living, actually 4. 1, 2, 3, 4. Yeah, 5. Right? So we have 1 period, 2 period, 3 period, 4, 5 period, right? So we need to see what's the probability that he will be alive. So I use L3. It's easier for me. Why? Because I'm gonna throw I'm gonna throw 1000 lives here and trace them. I'm gonna trace the 1000 here, but we need the probability, right? We need the probability to trace the 1000, right? Let's put it here so it helps us to see the probability. Now we start age 30, right? And we are here, right? Do you see it? So now this one will be, now the Q here, the death here is 0, 0, 5, 5, right? Do you see it? And now this death here is 0, 6, 5. The death here is 0, 7, 5. The mortality rate, I mean. Now you go this way, because this, it tells you Q34 is 0, 8. And the last one is 0, 8, 5, right? Let's call it Q. You see how I got them, right? It's simple. You start with the first one. It's 30 plus 1. So we need, so somebody's age 30. So this is 30. And now we keep, 30. Now X is 30 plus 1. So this tells us, so Q Q30 plus 1. So somebody here, Q30 plus 1. Right? Let's, right? It's Q30 plus 1 it's from here. Q30 plus 2 here. This is, right? So you keep, and when you reach here, then you go down here, right? 33, 34, 35, 36. Right? Simple. Now, if you do this, why I'm doing this, we start with 1000. Now, this is mortality. Let's write it. Now, we need LX now. The L here is 1000. So let's look at this one. So let's say we start with L30 plus 1. Now L30 plus 2. How we calculate L30 plus 2? It's simply you take the 1000. Let's write it here. L30 plus 2. We start with 1000 multiplied by 1 minus 0.055. Right, so who survives? So 1 minus so I have here is, now here you will have 945. Now keep it in your calculator, don't remove it from your calculator. Right? Why don't remove it? Because you need to multiply it by 1 minus 0.6 by this 1 minus this one. So multiplied by 1 minus 0.065. Now this I got 883.575. Now you need to multiply it now by 1 minus this one. Now we here multiplied by 1 minus 0.075. So it goes down now to 817.306. And now this one, you multiply it by 1 minus 0.8 now. It goes down to 751.92. Now the last one here is multiplied by the last probability, 85, like 8.5%. So multiplied by 1 minus 0.085. The last probability I got 688. This is the last one I got, right? So what is here is equal L36, remember where it is? Take it here, 688.09, and easy because we started with 1000. So the answer will be it's very easy, but you need to be focused. It's simple if you use the logic I did. Again, where I got the 1000 from, the 1000, I assume it. You can assume 10,000, 1 million, 100, whatever you want. I usually start 1000 or 10,000 because sometimes I need more decimal. And I put it there and I trace what happens to it based on the mortality table. See how many people is still alive, right? So let's take another example now. Right? Let's take another example. Let's use the same table. You might be given different table. It might, but let's use the same one here. Let's have the second question as well. Remember I said there are two people, Mr. A and Mrs. B. Now let's take Mrs. B. Now, oh, no, this is, we did this one. Let's do the second one, sorry. Where is the image? Yeah, here it is. Question 2, I meant. Seems I didn't save it or what? Sorry, I didn't save the question, but okay, let me look it up, the question. I have it on my note. Sorry, not this one. The question is, if I still have it on my note, I was working on it. So now Mrs. B was newly selected. Let me use the same. Was newly selected on 1/1/2000. So was newly selected on 1/1/2011 at age. So she was newly selected now on 1/1 at 2011 at age 31. So the question here is find probability that on 1/1/2013. So we need, we need to find the probability on 1/1/2013. So the probability evaluated in 1/1/2013, we need to find the probability that Mrs. B will be alive on 1/1/2016. So we wanted to see the probability for Mrs. B be still alive on 1/1/2016. But what we wanted to look at the information, what's given. Newly selected on 1/1/2011 at age 31. So the selection is 31, right? Right. So it was selected at age 31. And here we need to look at the evaluation of the probability. So what goes in the denominator is 2000 and 2013, and then to see if she's still alive. So we're looking at survival. Let's draw a line and see what it is. See what summarizing the information in the line. So now she was selected on 1/1/2011. So 1/1/2011. This was selected at age 31. So now 12, 13, the year, here is the year, 14, 15, 16. We wanted to see if she is still alive by 1/1/2016, right? So let's trace her age. Her age 31 on 2012, she will be 31 plus 1. She's still selected. Here will be 31 plus 2. Right? And here will be 31. Oh, sorry, here actually end of the period, because the selection only plus 2. Right? The selection is only plus 2. So here will be 34 actually. 35, 36. This is the age, right? So the year of evaluation, we are evaluating here. So let's take now the lab table and see how we can do that. So what we wanted is the probability that L36 divided by, because the year of evaluation is here, is L31 plus 2, right? As always, the first year of you looking at the year of evaluation, just give it, assuming this L is, give it 1000. Come up with, you know, like a cohort, and then let's trace the cohort and see how it will evolve based on the life table we are given. So let's trace this cohort based on the life table we are given. Let's trace this cohort based on the life table we are given. So now remember that she was selected at age 31. So we are looking at this line. Selected at age 31. And we want it to start from here. So here. So this is the starting period, right? So let's put the mortality here. So Q30 plus 2 will be 7%. Let's put it here, so we don't forget about it, right? And then if you go forward, this will be, the next one is 0, 8, right? Then you go down, because 34, you need to go to 35. 35, the age 35, to survive it is 0085. Right? Do you see what I did here? I traced, started, well, we first started that selected on 31. Then we're not interested in this. We moved to the year we are interested in here. And then we traced, we got as many years as we wanted. We got the mortalities here, right? So now 1 minus the mortality, this is mortality. Now P, or survival, will be 0.93, 0.92, 0.915, right? Correct? This is the survival. This mortality, this survival. So let's look at this one. We said the denominator is 1000. Now let's trace this 1000. 1000, 1 minus 0.07, or 1000 multiplied by 0.93, where we got the 93 is the complement of the mortality. It gives us 930. Now we multiply it, so I multiply it with this. Now I multiply it by this. 855.6. Now we multiply it by 0.915. So the answer is simple. Okay, that's very easy. So like, this is really easy as long as you understand the terms. You read the question very carefully. Like, the question is very carefully. What year, when was selected, and what is the year of evaluation, because it goes to the denominator, and what is it survival, is it, you need to read the question very carefully and then translate it into this. And what you see here, the life table is expressed in QX. Other questions you might then, you know, like, you have QX and then you assume LX, but it might be given to you, the life table, it might be expressed to you in different way as well. Instead of mortality, you might have the select life table like this. Right? So if it's given to you this way, it's easier, right? Or, I mean, as easy as the other one. So why I'm saying it's easy, because then you can express, you can instead of assuming what numbers you put here, the L, these numbers, instead of assuming them, you can actually take them from here right away. You can take them from here and then calculate the probability yourself. Regardless the way it's presented to you, whatever the way it's presented to you, you can still you know, do the calculation, right? It's simple. Both of them, they take you to the same thing. You can get the QX easily, or PX, or anything. And again, like to summarize, we need to look at ultimate, which is starting here, you know, it becomes ultimate, and select. Select is this period, right? It's important for us to understand these concepts. Before this session, actually, I hope you guys, you did the what we call it, like the problem set that I put on the previous lessons. So I put it. I hope you solve it. Again, actuarial mathematics, you need to solve as many problems as you can. It's very important to do lots of practice and problems, and in live sessions we will do some also problem solving. All right, talk to you on another session.